Hey, sorry, doing some adjusting. All right, now I've drawn out, this is the same exact picture that I drew the other day, and I'm gonna give you guys a test tomorrow, okay? Obviously, you're gonna be able to use this video along with all the other videos, but I'm gonna go through what I feel like you should know by now after everything that we've gone through, okay? After everything we've gone over, you should be able to explain the water cycle to me like this, the way I'm about to explain it to you, okay? So I'm gonna start just with evaporation, okay? Obviously, what does the water cycle always have to have? The sun, okay? Because the sun starts it all, okay? The sun beats down on the earth, beats down on water. It turns this water, it turns it into a vapor, okay? It's turned into a vapor. And what type of vapor is it? Okay, and we should know this because the sun heated it up, so it should be warm vapor. And what does warm vapor want to do? Warm things want to go up. So warm vapor rises. Now, one of the more important things you need to know that you might get asked on the EOG, if we take the EOG, I have no idea if we will or not, is what are the two ways that water can be evaporated? What starts evaporation? Obviously, I just told you one of them. It's the sun. And what does the sun make? That we haven't really learned yet, but you will learn it. It's kind of complicated. The sun makes the wind. Those are the two ways that water can be evaporated from the earth, okay? Wind can pick up water and take it up into the atmosphere. You guys have probably seen that before. You know, a storm comes through, your driveway's super duper wet, it's super windy, and the wind kind of dries it up. Well, the wind is basically evaporating that water, okay? So this warm vapor starts to go upward, okay? And you cannot see it. And remember, if you ever get confused, the word vapor is in evaporation, okay? The warm vapor wants to rise because it's warm, all right? Warm things want to go up, just like biscuits at Hardee's or McDonald's. They rise, just like bread should. It goes up into the atmosphere and it's gone through this physical change of going from liquid water into a vapor that's invisible. And then it hits the cold air. And then this change happens again. It goes from being a vapor because of this cold air, and it turns back into liquid water, and these little droplets start forming, and they start grabbing dust, and that's when a cloud is formed, okay? So the cloud sits up there, and remember, inside of every raindrop is one speck of dust. So that'll prove to you that this does indeed happen. These water droplets start to join together, and they make these water droplets with one speck of dust in them, okay? That cold air is what's so important. The warm meeting the cold is the reaction that causes the clouds to form. Now, once the clouds get so full of water that they can't hold them anymore, they purge the water. They release the water, okay? And the water can come down in 5 forms of precipitation, okay? It can come down as rain, hail, which we talked about yesterday, sleet, snow, and the most dangerous of all of them, in my opinion, in the winter, the freezing rain, because freezing rain coats everything, coats the roads, you can't really see it, it's very dangerous, very icy. So one of these forms of precipitation falls from the cloud. Generally, we always see rain around here because of our climate. You know, our climate is a warming climate, you know, and we generally always see rain. We can sometimes see hail and definitely see some frozen precipitation in the winter. But remember that hail is the only frozen precipitation that is going to fall in the summer, okay? I guess on a rare occasion it could possibly fall in the winter. I don't think we'd be able to tell the difference though. You know, if it did fall in the winter, it'd be like, oh, it's hail outside, as opposed to some other frozen precipitation. But I've never heard of hail falling in the winter. So this precipitation falls to the earth and it causes runoff. And remember that runoff is going to be when water goes to its lowest possible point, generally to another water source. Okay, so you're going to run off into rivers, lakes, streams, oceans, and also underground. Now, groundwater is really a different type of runoff. And the reason it is because these right here, the sun and the wind can get to them and they can evaporate. But if water goes down to groundwater, it loses the ability of the sun to reach it and the wind can't get it either. So groundwater usually does not evaporate. Okay? And the reason it does not is because there is nothing to make it evaporate. There's no sun. The sun can't go through the land. The wind can't go underneath the ground. So there's nothing there to evaporate this water, so it just stays there. And sometimes it ends up in our drinking water. We pump the water out of the ground and we drink it. A lot of people with wells do that. So groundwater is kind of the strange one, okay? Because all these other ones can be sucked up by the sun and the wind, okay? And turned into this vapor. Now, the last part is going to be transpiration. And I noticed some of you guys' answers. When we started talking about transpiration, I think there was some confusion. Transpiration is the release of water vapor. Okay? The release of water vapor from all plants that are green. It can even be green grass in your yard. Anything that's green, anything that grows is going to go through transpiration, because some of these plants, when they start soaking up water, they soak up too much. And if they soak up too much water, it can cause them to rot. So they learn how to release it from their leaves. Now, here's a really crazy thing. In the fall and the winter, they don't transpire around here, because what happens to our leaves? They all fall off. They die. The trees cut their water off, and the leaves don't have any more water to stay green, so they begin to die and they fall off the tree because there's no water there anymore. And then obviously in the spring, the trees know that that warm air is coming. They can turn their water back on. The leaves can start popping back out, and then we have leaves again, only to have them die again in the fall. Okay, so when things transpire, that's going to be plants. Remember, you don't transpire, you perspire. You go through perspiration, and that's what makes your underarms and things like that get sweaty. It's perspiration. When you sweat on your head, that's perspiration. So you're kind of releasing this vapor, but it's just a different way of saying it. Your trees and plants transpire, you perspire, okay? Now, in my opinion, I think that most of you should be able to explain this to me just like I explained it to you, okay? And tomorrow, you're gonna have a 10-question multiple choice test, which you can use this video. You can use any video that I've done to try to answer your questions, because I want everyone to get a good grade. So that's all I've got for you today. I'm gonna start going over lows and high pressures tomorrow, because we're gonna start doing hurricanes next week. And it's very fitting because there was just a massive hurricane that hit the Gulf of Mexico. You guys have probably seen it on the news. It was a monumental event in weather history. Just a horrible hurricane, and we'll talk about those next week. But I have all this written down, so it would probably help you if you paused and looked at the picture and see if you could really explain it to me if I asked you to. And that's when you know that you have complete understanding of the water cycle. And remember, this is going to take us on to the next parts of weather. You kind of got to understand how this cycle works. It's a never-ending thing, thank goodness, because if it were ending, then we wouldn't have any fresh water, and obviously we wouldn't be able to make it. All right, so if you need any help, please Google message me, Google Classroom message me. You can email me, get your parents to send me a talking points. I'll be glad to help you in any way I can. And I hope you have a great Thursday, okay?